You need to learn about the 4 golden signals right now, because when you do, you'll stop getting errors in your code. Okay, that's not entirely true, but they will help you find errors a lot quicker. So let's go through them. Latency, errors, traffic, and saturation. Let's, or tells. These are the 4 key metrics according to Google that you need to keep track of because they'll give you a clear picture of how well your system is doing. Let's go through each of them in detail. To help with these explanations, we'll be using the OpenTelemetry demo running on an EC2 instance with Docker. This is basically a fake e-commerce site where you can buy telescopes, a flashlight, binoculars, and some other things. It's made up of 20 different microservices and uses a locust load generator to simulate traffic, then collects telemetry data from these microservices using the OpenTelemetry collector. It also comes with some feature flags and some pre-made dashboards, which we'll use to explain the golden signals. If you want to install this, then head on over to the OpenTelemetry website and follow the instructions for either Docker or Kubernetes. Okay, first we'll explain the 4 golden signals. Then once we're done with that, we'll change some feature flags for a specific service and see how other services are affected. Cool. Let's get started by explaining latency. This is the time from when a request is sent to when a response is received, usually measured in milliseconds. So network latency, database query time, application processing time, and those kind of things. In fact, let's go through an example. So if we look at latency for the front-end service, we can see we have different queries for different quantiles. For quantile 99, which will be 1% of users, they could have a latency of over 365 milliseconds. And for the least amount of users, so quantile 999, they could experience a latency of over 724 milliseconds. But it looks like for the majority of users, they get under 200 milliseconds. Okay, let's move on to errors. Errors are the number of responses that fail over time. So this could be a HTTP 500 response, a 200 with incorrect content, or even a response that fails to meet a custom threshold like latency time over 500 milliseconds. Here is the error rate from the front-end service in the last 30 minutes. And in this case, the error rates are a percentage collected every 2 minutes. Now, for the router image provider egress and the router Grafana egress, the error rate stays at 0%. But if we move on to the router frontend egress, then we can see it steadily goes up and down and then rises over here. The ingress span name also has a similar pattern. Now, if you want to know exactly why this is happening, then stick till the end. But in general, if you see an error rate visual following this trajectory, then it's something that should be looked into. Moving on to traffic. Traffic is the volume or amount of requests a system is handling, and it's typically measured in requests per second. This is a really interesting visual because it's combining traffic data from both the cart service and the val-key cache. Now, if we look at the yellow graph, this is getting data from the cache, so the hget, and below it in purple is a post method for the cart service. Now, both of these calls have a higher request rate compared to these two down here. So these two are a second or over, and these two are below 200 milliseconds. Okay, moving on to the final golden signal, saturation. Saturation is basically how full your system is or how close it is to hitting its resource limits. This is most likely what you expect to see when you're monitoring a system. So things like CPU and memory for these Python services, and also recommendation rate, which is the rate that recommendations are made every 2 minutes, and recommendations are found on a product page, and also quote service batch span processor, which shows quote service spans that were batch processed to the OTel collector. Okay, now that we have a better understanding of the 4 golden signals, let's experiment with some feature flags and see how they affect these metrics. But before we do that, let's talk about PromQL. I mean, isn't it cool that you can use the Prometheus query language to create visuals in Grafana? But you can also use it to create visuals in BetterStack. BetterStack is the best way to manage all of your observability data. Not only can you create dashboards using PromQL queries, but you can also create status pages, set alerts, manage incidents, search through logs, and much more. We even have a really generous free tier to help you get started. So go and check out BetterStack right now. Okay, we're back. Let's now play around with some feature flags. Now, the whole time I was recording, I had this feature flag turned on, which fails the product catalog on a specific product. So with that feature flag on, this product catalog service should have some errors, as well as the checkout service, the front-end service, and the front-end proxy. Let's go and have a look at these metrics. So we can see that in the last 45 minutes, the product catalog has had an increase in error rates produced by spans. And by the way, this whole section is called span metrics because it collects metrics from trace spans, which means if we take a look at the traces from the product catalog in Jaeger, we should also see some errors that correlate to what we're seeing in Grafana. Going back to Grafana, we can see that for the front-end service, we also have an increase in errors, and also for the front-end proxy. This is why the front-end proxy example from earlier started to show an increase in error rates. The checkout service also has some errors, but it doesn't seem to be exactly in line with the other services. Let's change another feature flag. We're going to turn this one off, and we're going to turn payment unreachable on. This now means that when someone is on the checkout page, the place order button will not work. So what services will that affect? Well, we can see that if no one can access the payment service, then there should be less requests from it. Also, there should be errors on the checkout service since it's making calls for the payment service, which are not being received. Let's take a look at Grafana to see if that's the case. And we can see that for the payment service, all the requests have gone down because no one's able to access it. Also, we can see that there are now errors on the checkout service for trying to access the payment service. Now, if I wanted to, I could continue changing feature flags to see what effect they'll have on other services. But I think from this, you can already see how important it is to keep track of golden signals. If you enjoyed this video and want to see more like it, then hey, why don't you subscribe?